Hello and welcome to the part 2 of this presentation on evaluating BI4ALL for purchase in your organization. Thank you very much for returning. Now at this point in time you might be saying, well, now thank you very much for explaining like the history of where BI4ALL came from and the history of the modeling techniques and positioning BI4ALL as much cheaper, much faster, much more flexible, much easier to implement than other data models. Now, that's all good, we need to understand that, but enough of background, show me something new. And this would be the right place to be at this point in time, show me something new. So we'll talk about how does BI4ALL solve these problems, the three major problems. Trivial to understand. We do this by having a concept called everything is linked to everything. That is, we have a mechanism, which we now call the mesh, which allows tables to be meshed together and everything gets linked, and if it should be linked, it will be. Now, the huge breakthrough that this is you no longer need to draw diagrams. You no longer need to have a mental picture of what the data model looks like in your head. And in years gone past, we needed to have a mental picture of the data model. That's how we did things, and we had pictures of data models on walls. And most people still need pictures of data models in order to mentally understand them. The issue with needing a picture of a data model in order to mentally understand it is that you get limited by what you can then draw in a picture. And if you can't draw it in the picture, then you can't ingest it and understand it. The breakthrough was by no longer needing to draw anything on a picture, to be able to understand the model without the necessity to abstract it into a diagram, we can build now much more complex models without needing to remember where anything is in particular. And this was a huge breakthrough. We dramatically reduced the customization time. We use an extremely small number of physical tables during development, and physical objects are built at testing time, not at design time. So we can build our data warehouse on 20 or 30 tables, if even that. Sometimes we implement the prototypes on as little as a dozen tables. So when you only have to manage 10 or 12 tables in the development phase of your project, that saves you an awful lot of time and effort. And on databases like Sybase IQ, you can go live with that sort of thing. There's no difference in performance on Sybase IQ whether you implement a large number of tables or a small number of tables, and we do all this through views, so we dramatically reduce the customization time. The other thing we did to dramatically reduce the customization time was to use CTL, which is our data warehousing toolkit, to be able to also manage data models. And you'll see that during the demonstration. So being able to use CTL to manage data models dramatically reduced the amount of time and effort it took to customize physical models. In terms of null fields, we dramatically reduced the number of null fields that get populated into the production data warehouse. This was quite important when we were implementing on databases like Oracle, where a null actually does cost some disk and does cost processing in terms of querying and storage of the data. So by reducing the number of null fields, we improved quite significantly the storage and performance, particularly on Oracle databases. Now this is becoming less important because more databases are figuring out how to bitmap nulls and things like that. We have in our data models an extremely high level of reuse of physical fields. Nearly all physical fields have meaningless names and can be reused by different views that are being placed into that field. We match the field names on the data type, not by content. So if you have a string field, varchar 255, you can put anything that's a string into that field. You don't need to worry about it. Same with integers, decimals, money fields, floats. Whatever the data type of the field is, you can put a field of that data type into it. And that field can be reused quite heavily. And by reusing fields quite heavily, we have a much smaller number of physical objects, therefore less indexes, less tables, less maintenance, and all the rest of it. and a high level of reuse, which means less empty fields. In BI4ALL, all tables are presented through views, and so data can be moved between tables with no impact on applications, because we move the data from one table to another table, but we have a view number in the data, and we expose that table through the view. So we move the data from one table to another, we delete it out of the first table, we rerun the view, and voila, we've now moved the data from one physical table to another table with no application impact. And so this ability to manage the physical placement of data into various tables and move it around to various tables, including creating its own table for it to live in, is far more flexible than what you'll see through other data modeling techniques. And it makes for an extremely easy to manage a physical table environment. Now, we want to also make clear 2 points about BI4ALL, our philosophy of development, and how we stack up against competitors. So we provide a toolkit for customization, okay? And you need to understand it is a toolkit for customization. We're not saying we provide your finished data model and here it is and it's a licensable product with upgrades. That's not the route we went down. And we went down this route quite deliberately because there are significant benefits or significant advantages to doing it this way as opposed to disadvantages for trying to create a finished data model with finished applications. So we provide things like the key structures, the audit fields, and the common data fields which you will commonly find across many organizations. You add your own data fields and you can use your own naming standards which are already defined and consistent inside your organization. Indeed, inside the physical, for the views of the tables, you can rename our tables to your own naming standards should you so please, okay? You can put a layer on top. We can deliver you the BI4ALL model at the ETL stage. You can put a layer on top of that if you want to abstract and rename the tables and the fields if you have an existing naming standard. So with BI4ALL, you don't have to adopt our naming standards for your organization, which in a large organization can be a massive undertaking. We say you can use our data models and all the tools and techniques of our data models without adopting everything to do with our naming standard, okay? We're the only guys who enable you to do that. I don't know anybody else who enables you to do that. If you know somebody else who enables you to do that, please let us know. So you add your own data fields to your own naming standards, and you can even replicate or overlay your naming standards on the top of our data models. And we do that by supporting 10 view layers on top of the model. This was intended to support 10 languages, but it can support different naming standards as well. Now, after customization, you own the IP of the model on license. It's your data model. It's no longer our data model which we upgrade and re-release to you. It's your data model for you to then further extend as you see fit. You get, in the end, a unique data model, your data model. Now, if you want us to maintain your data model, or one of our business partners to maintain your data model, then that's fine. Our competitors sell data models where they usually include every field known to man, which is a superset of most things that they've seen, which runs into so many fields, but when you implement them, many of them, if not the majority of them, are empty, and that costs you disk and processing, which they will be only too happy to sell you. They typically license their products or data models as a product that they own and you upgrade. So they require you to go through the upgrade processes in the future. And of course, each upgrade cycle costs you time and money. And these distinctions alone makes our competitors much more expensive than BI4ALL. For example, if you're a small company, you get BI4ALL for €1,000 a month. Okay? €1,000 a month, it's a rounding error, right? If you're a big company, it's €2,000 a month. If you ring up our friends and colleagues at Teradata and IBM and Oracle and SAP, 1 or 2,000 euros a month is going to be laughable in what they're talking about. So just a little word on our competitors, because typically it's not good form to talk directly about your competitors, but I don't mind doing that. Our major competitors, and this is quite an achievement for us, our major competitors are Teradata, IBM, Oracle, and our friends at SAP. Now, Oracle and SAP have a very different offering to Teradata and IBM because of their ERP implementations. So Oracle and SAP tend to say, if you have our ERPs, then we've got a data warehousing solution for you. And they tend to link their data warehousing solution very much to their ERPs because their ERPs are where the big money is. Now, each has a very different offering to each other and to us. What Teradata offers is very different to what IBM offers, is different to Oracle, is different to SAP. But the major differentiators between us and the big four, you might want to call them, are really as follows. First of all, the license cost. We're now making BI4ALL available as an MLC, which means for all intents and purposes it's free. If you don't like it, stop paying for it. It's as simple as that. And it's a fraction of even getting started with the big four. Customization. We provide a toolkit to customize, not a finished product that you have to upgrade, etc., forever after. Ownership. You own the output of the customization process. It's your unique data model that you get at the end. What you get with competitors is typically it's our data model. Yes, you customized it, but it's our model and we're going to upgrade it, and you're going to take the upgrades and pay for them, and you're going to be happy with that, Mr. Customer. The implementation effort is BI4ALL is vastly easier to implement than anything from those four guys. Ongoing costs. You use less disk and CPU and therefore smaller machines for exactly the same result. For an equivalent capability, no loss of capability in the database space, we can get you up and running with less disk and less CPU and smaller machines. Obviously, the only one of those four who doesn't sell you hardware is SAP, although they'd be very happy to sell you some HP machines, right? So Teradata, IBM, Oracle are all selling you hardware, and so selling you more hardware is good, right? Given that we can get you going on less disk and less CPU and smaller machines also mean lower database fees. Okay, fewer CPUs worth of database licenses, and all four of those sell you database licenses. So in their point of view, more database licenses is good. From our point of view, saving you some money on database licenses is to your benefit. So having said that, let's talk about now how to read BI4ALL models. And this is really kind of the point that if you're a business sponsor or a business analyst, you might want to start thinking about, this is going to be getting a little bit technical from here on in. And it does get a little bit technical from here on in. So the first thing you need to understand is the table name terminology. And tables are linked, if they should be. So a fact table. Everybody in this audience should understand that a fact table stores facts, which is numbers about a business, such as revenue, profit, cost, price, quantity, etc. And we have what we call major dimensions and minor dimensions. So a dimension table we would refer to as a major dimension. So a table containing dimension fields about a specific major dimension of the business, e.g. time, product, customer, we would refer to as a major dimension in our nomenclature. Minor dimension is what we would call a dimension field. So generally a descriptive character field describing some aspect of some object that is involved in the business. So you have time, product, and customer as your major dimensions. So you would have day, week, month, quarter, year would be considered minor dimensions. Name, color, size, weight, height, group, category would be product minor dimensions. For customer, it would be name, birth date, age, sex, marital status, life stage, those sort of things for minor dimensions. So that's how we call things. We have a association table type 1, And an association table type 1 associates two or more tables to each other. So for example, if customer 1 is the wife of customer 2, and customer 2 is the husband of customer 1, then that would be stored in an association table. If customer 1 lived at address A and customer 2 lived at address B, that would be stored in an association table. We have an association table type 2, and this is a table that provides time variance support within a star schema, and how this is done is confidential, and you need to have signed a non-disclosure agreement to be told about that, and we will get to that section. We have type 1 dimension tables, where we replace the record when some fields in the record changes. Standard, you can read it in Ralph Kimball's books. We have a type 2 dimension table, which closes the previous record and opens a new record when some specific fields on the dimension table change, and you can name one or more fields on the dimension table to investigate for change for a type 2 dimension table. So in terms of terminology, just on this diagram, and this is of course your simplest of simple diagrams, you have integer keys put onto your fact tables. So this is a fact table. It has amount, cost, and number of transactions, and these are facts. You have integer keys on your dimension tables. These tables would be described as major dimensions, and these fields would be described as minor dimensions. And if this isn't immediately obvious to you, or you don't know this, then you should quit about now, okay? Because this is as least technical as we can explain it. So the naming standards, when we start showing you physical things, TD means table, dimension, TF means table, fact, VM means view, dimension, and VF means view, fact, in the standard model as it comes out of the box. And we'll go into that more. So what's BI4ALL coverage today? We could list a lot of things on here over and above what we have. So the simple things to list are campaign management, marketing, sales, customer credit scoring, customer behavior analysis, relationships, product catalog segmentation, invoices, payments, deliveries, returns, accounts payables, vendors, accounts receivable, general ledger, bit of HR, bit of credit risk, customer saves. We'll go through all those now as we go through the presentation. So the coverage in BI4ALL itself is extremely broad, and we're about to go through that. So the tables in BI4ALL today. There are 94 fact tables in BI4ALL today, and these are them. These are all the fact tables listed, all 94 of them that are in BI4ALL. And we're going to go through, actually talk about them in a little bit, and then go through them in views, okay? So, in terms of talking about each fact table in a little bit, account close transactions. If you close an account, then you'll get a transaction. If you, the dimensions which are associated with an account, get a fact table. The account measures, get a fact table. The account plan gets a fact table, and the account transaction get a fact table. So I'll just explain measures, plan, and transactions for a second. Where there is a transaction, we then have to choose whether we're going to have plans for that transaction and then accumulated measures for that transaction, as well as the transaction itself. Now, not all transaction tables have got plans and measures. Plans as in plan forward, measures as in aggregation of the transaction. You can see here on account close, we don't have plan and measures, but on accounts themselves, we do have plan and measures. Now, obviously on account close, we could develop plans and measures. That wouldn't be very difficult at all. But we don't have plans and measures for everything. So I just thought I would mention the three different types of those fact tables. Now we have account to product association, so the products that are being used on various accounts. the address to address archive. So we can archive the relationship between addresses over time. So when an address ceases to be related to another address, we archive that. We have the address to address association. We have the address to a map reference. I'll move the cursor off the screen because it will probably just disturb you. So you can listen and you can read along. We have the address to map reference. So if you have some mapping software and you want to link the mapping software to the address, we actually have an association table which allows you to link mapping software to addresses through our data model if you want. Adjustments. Adjustments happen in all businesses, so we have an adjustment account and a measure. We have the accounts payable information, so the account payable header in the line, and then the account payable measure and transaction for all the accounts payable invoices. We have a campaign submodel, so we have campaign dimensions being associated and a campaign exclusion association. So if I create a rule to exclude people from campaigns, and I put the people to be excluded from that campaign into that campaign exclusion rule. We have contracts, so contract dimensions, the contract end date, the contract end transaction. So when a contract ends, we get a transaction. When a contract, we had contract transactions and we had contract measures, but no contract plan. Credit limit breaches, so when somebody goes over their credit limit, but say the service is not suspended at a telephone company. We have a credit limit breach transaction, and we have plans and measures for credit limit breaches. So this is for any standardized business. Customer contacts, we have the measures and transactions for customer contracts. For debt treatments, say a person goes into debt with us and is not paying their account, then we have treatments, various ways of dealing with that debt. And so a debt treatment transaction gets generated, say a phone call or a visit from the boys and say we're going to break your kneecaps, whatever you have for your debt treatment transaction. And then we have plans and measures for the debt treatment transaction. We have customer save efforts. So, a customer might ring up and say he wants to cancel his account, or he might ask questions which lead you to suspect from profiling that the customer is considering cancelling his account. So a customer save transaction is a treatment that happens perhaps proactively, perhaps reactively, to save the customer from terminating their product or service. So we have a transaction and a plan and measures for customer save transactions. We have customer measures, just to measure how customers are performing as a group over time. We have delivery transactions and measures, no plans. We have the exchange rate association, because everyone has to have exchange rates. For fraud, we have a transaction table to detect the occurrence of a fraud or to record the occurrence of an actual or suspected fraud. And we have plan and measures tables for fraud. We have the file transfer run log. So within every data warehouse, there's lots of file transfers going on, and we include the file transfers in the data model. So we have a file transfer run log transaction. We have plans and measures against the file transfers. In terms of GL, we have the GL account balance, the GL account transaction, and the GL header, and then the GL account to dimensions association, which is a part of the archival process. We have household to address association. So if this household is associated with that address, we keep that as an association. For invoices, we have the invoice header, the invoice line. We have invoice measures and invoice transactions, just in case invoice transactions are different in some way, shape or form to invoice lines. Obviously, we also then have orders. So we have the order header, the order line. We also do order line archives and order measures and transactions. And I'll explain the order line archive. What this is in many organizations, The order itself is flexible and can change over the life of the order until the product is actually shipped, in which case once it's shipped it becomes a return. So what happens is order lines twinkle and change over time, and so we actually implemented an archive to record each change of each order line. So you can see how order lines changed over time, which is actually very handy. The organisation to address association, so if this is a company, the organisation to the address association, a party to address archive association, and a party to address association. So if a party is associated with an address for any reason, and that party can be a person, organisation or household, then we keep the existing association, and when it closes we archive that, or when it changes we might archive that as well. We then have the party to dimensions association, which links all the different types of dimensions to a party. We have the party to party association archive and the party to party association. So when two parties are associated together, we put that information into the party to party association, and we also maintain an archive of the party to party associations as well. Okay, somewhat redundantly, but we like that little bit of redundancy. Person to address association, person to household association, person to organisation association, and the person to person association. Okay, so these are all the associations between parties broken out as households, organisations and persons, and the way in which they relate to each other. We next have product measures, so the performance of products and product groups over time, and we have product plans to go along with product measures. With results of campaigns, we have response transactions and response measures. So as you have solicitations and responses, we track all the response transactions. Return transactions and measures from selling goods. When the good returns, you have a return transaction. We have a sale account measures. So this is relating the sales to the accounts and measuring them. We have a sales transaction. So every time a sale happens, a row goes into the sales transaction. And we even have things like the probability of the transaction becoming a return, so that we can calculate sales taking into account the forecasted return rate for the products that are returnable, and we age those return probabilities over time. And we have sales plan, and we have measures against the sales plan. Down the bottom here we have solicitation measures and transactions, and we will go through these tables in a little while and you'll actually see the tables themselves, right? We have a sophisticated segmentation engine, and we think this is pretty cool, specifically for retail, but can be used for other things as well. And the way that this works is that we score each transaction, usually a sales transaction or a usage transaction, and against this sales or usage transaction, we can place the transaction in up to 64 segments. So we designed our segmentation engine to contain 64 segments for a segmentation plan. So an individual product can have one of 64 segments applied to it. And the total number of segments in the segmentation model is 64, but of course different products can go into different segments, and you can have different descriptions of these segments and things like that, and different versions of descriptions of different segments. It gets quite complicated. So the first thing is, and then for each sale, we score the product typically between 0 and 10. 0 means this product does not contribute to this segment. 1 is this product has a loose association with this segment, a weak association with this segment. And 10 being this product has a strong association with this segment. So you can rank the product sale transaction 0 through 10 from no association to a very strong association with this segment. Then based on that, we calculate the segment frequency, the monetary value and a monetary proxy. Okay, so the actual value and then a proxy for the actual value, because proxies can be normalized a little bit and the groupings can be done more effectively, and the proxy can be quadrants or quintiles, those sorts of things. We have frequency and then rows. So in each of these cases, we have the table in two different formats. One is the product and the row with the 64 segment numbers out to the right, and the next one is the product or the rows with up to 64 records, one for each participation in each segment. Now in the rows to the right with 0 to 64 columns, if a sale or product doesn't participate in a segment for the period, the total number of points will be 0. But in the rows, because we don't want to generate a row for a 0, the absence of the row says that the number of points scored for that column, for that product, for that period is 0. So in one it is a 0 in the column, and the other it is the absence of the row. And that's used for reporting purposes. So we have frequency, the monetary proxy, the actual monetary value, and then the points that were scored by the product for the customer for the period, and then the recency for that product. How recently was it purchased, i.e. 1 month ago, 2 months ago, 3 months ago, things like that. And then we have the segment rows themselves. And then we have statistics, which are calculated and stored, and you can calculate and store a wide variety of statistics. Indeed, you can make them up yourself. So these are the 94 fact tables that come standard out of the box with BI4ALL. Now obviously, when you look at these tables, this is pretty much everything you do in a standard kind of company. It's a very rich base from which to work. And then if you want to add more to it, then you can add more to it. But we'll go through these tables in a little while and show you exactly how they work. Yeah. Now, in terms of dimension tables, the current BI4ALL data model has 242 dimension tables in it, which is a large number of dimension tables. But I will say, in defense of the large number, we tend to create a dimension table for each measure and period, date and minute. So you can see here account measures period, account plan period, account transaction date, account transaction minute. So we create these different tables. They're obviously all laid over the particular underlying table as a view, but we create them with different names to be able to alias them back to the underlying table to make it easier to build queries on and things like that. So obviously the account transaction date is the exact same table as, let's find another date, the contact date. Okay, so account transaction might happen on a certain date and a contact might happen on a certain date. This is the same underlying table, but we give the view different names so that we're not always continually aliasing something like VM day for all the different days or all the different dates, right? So we have, you might want to hit pause at this point and read through this, but I'll just talk through some of these. Okay, so we have the account close reason code, the account indicators, measures period, plan period, account status, you need an account status, the transaction date, the transaction minute, and account type. Now what I'll do is I'll skip over all the measures, the periods, dates, minutes type tables, yeah, because they're all fairly obvious. You have an account type, you have an address. We have address 1, 2 when we're relating addresses. We have an address archive, we have address indicators, which indicate things like flooding or earthquake risk and things like that. We have adjustment measures, period. Adjustment types. We have one which shows all customers and all demographics, just to expose all customers. We have accounts payable accounts, account payable account indicators, account payable account status, account payable account type, account payable invoice status, association code, association role, a behavior score model, blacklist reason, blacklist type, building types, breach action code, what to do when a breach action takes place, building types mistakenly there twice, campaign group, campaign hierarchy and the campaign hierarchy all, campaign priorities, campaign types, such as email, post office or real mail, letter drop, telephone calls, VM cards for the different card types, credit cards, and then the card types, company reporting structure, which is very important, contact date, contact method, contact minutes, contact preferences, then contracts, the definitions of contracts, the contract end reason code, contract indicators, contract start dates, contract statuses, contract type, credit breach action. So this is your breach action code, whatever the breach action might be, but then this is specifically a credit breach action, and then a credit class code, credit limit breach code, credit limit breach status, credit limit breach transaction dates and times, your credit rating, your currency 1 and 2 when you are creating exchange rates, your customer contact code, your customer contact status, your customer debt treatment code, your debt treatment status, your customer save code and customer save status, a customer value index, so we calculate customer values and link dimension tables to them for the index of the customer value, the customer status, the customer type code, of course date from, date to for everything that's type 2 dimensions. Your VM day is the underlying day for all the date tables. Delivery date, delivery instruction standards, delivery method, delivery priority, delivery status. Okay. Now the rest of them we'll go through. A dispute code when you're having a dispute status for disputes, document type, the ethnic group that the person comes from, the exchange rate type. For file transfers, the file code, the file status, the file transfer code, the file transfer fail reason code, if it failed, and the file transfer status. For financial scores and the model that the financial score belongs to. Follow-up method, would we go to follow somebody up on, say, the telephone, or follow up on Facebook, follow up on LinkedIn, follow up on email. Hell, follow up with paper, follow up with a personal meeting. Then all the fraud dimensions, the fraud close code, so what we closed out the fraud with, the fraud code itself, the fraud method code, how was the fraud perpetrated, fraud reason code, if we ever find out why the person committed the fraud, the status of the fraud, and then the fraud type. So they're all descriptive tables about fraud. Geocode, which includes geoeconomic coding and geography coding. Geography is down to postcode level, VM geography. Then GL accounts, we have the GL account, the GL account closed reason code, the GL account status, the account type, the book in the GL that the GL account code is in, the header status, the period, and dates associated, and then the GL transaction type. We have VM household, which is any household that we know about. Then we have households which are customers, as opposed to households we know which are not customers. We have household demographic information, industry classifications, so the things like the data providers classification for industries codes, language, invoice dimensions, then the language the person speaks or the various languages define, the type of limit for credit limits, the loyalty code, the loyalty program, and anything which is about an offer under the loyalty program for a loyalty program offer. Then we have map references to link geographies to and addresses to mapping style software, if we can have mapping style software. Market segments, where we actually have a mechanism for putting customers into market segments. Membership indicators, which type of groups or memberships does this person have, which groups do they belong to, which memberships do they have. Minute, month being time, order dates and periods and statuses. So the order date status or the order status, obviously the transactions, order transaction timing information. Organizational customers, so if the customer is an organization, they come out through that view. Organization demographic, and then the organization themselves. VM party is one of the key tables. This is a person, organization or household, which is an entity, generally considered a legal entity, which may do some kind of business with you. And then party 1 to party 2 for the association between parties, and then the party archive, where we throw the archived information about parties into the archive. In most organisations, payments happen, so there's a payment error code and payment error status and error type code, and then the payment method and the payment terms, like 60 days, 30 days, 60 days, 45 days, those sorts of things. For parties which are persons, we have VM person and then VM person 1 and 2 for the association, and VM person customers for parties who are persons who are also customers. Person demographics, so if we want to look at the demographics of individual persons, we go through that table. VM plan, where we have plan tables, plans can have versions, so we can create 4 or 5 versions of a plan and store the 4 or 5 versions of the plan, and then compare the measures table, which is the actuals, against the plan. We then have the primary sales rep, priorities, whatever the priority is linked to, product combination holdings, so which products does a person hold, indicators, and then the product cross holdings themselves. Then VM product, which is the product. VM product markers, which is used for the segmentation engine. That's where you have your 64 relationships between a product and the segments into which it contributes. VM profession, these are the various professions that a person can hold. Prospect source, where did a prospect come from? Psychographic indicators, what are the indicators for the person? Do they smoke? Are they high value? Do they like camping? Do they like fishing? Do they like women's magazines? These kind of indicators of the person, such that you might profile them for marketing campaigns. Response type and the time information. Return reason code, why was something returned to us? Then the run log information, so the run log measures, plan, transaction information to be able to analyze the processing run logs. The sales date and period, those sorts of things. The sales rep that made the sale. Then the save information, the save period information. Schedule status for the run logs and for the execution of whatever the schedule says it is. The schedule type code for the various schedules. Then in the segmentation engine, we have the segment code itself, then the relationship between the segment code for 1 and 2 to relate segment codes to each other. Then we have the segment codes as a set of columns to string out across reports on the 64 wide columns. We have the segmentation run log, and we can actually run our segmentation engine multiple times per period against multiple different segmentation plans and multiple different segmentation styles. So instead of having people argue about, we think this segmentation method is better than that segmentation method, we think this set of scoring points is better than that set of scoring points, we have the ability to run them all, store them all, and then compare them all with each other such that we don't lose any information. You don't have to sort out the one way of segmenting things. You can have various different ways of segmenting things, running them all in the same period to then compare them all. So we have this segmentation version, which is very important. Dimension tables related to solicitations, including solicitation type. Then we have the source file code to describe a source file, start date minute, the statistics type codes and the various type of statistics you might have, averages, means, medians, modes, those sorts of things. Sub-campaign, target file code to describe target files, task types for the project planning, but also for things like follow-up, what's the type of task for the follow-up and things like that. Transaction information, including the transaction reason code, transaction status, transaction type. We have unit of measure, and then units of measure broken down by volume and weight. We have variance allowance to set the sensitivity of reporting, so you can vary between, say, 1% and 10%, and then that's going to red, amber, green your reports depending on whether the number is inside or outside variance, planned versus actual. And then VM vendor. So that's the list of tables inside the standard out-of-the-box model. So in terms of pricing, what you're being told is if you're not buying telco, retail, web or media, this is the set of tables you get for the fee of between 1,000 and 2,000 euros a month to start with and to create your data models with, rather than having to come up with them yourself. Okay, so quite an exhaustive list. Now what we're going to do next, I've just briefly gone over all the BI4ALL tables, is we're going to give you a source code demonstration. We're going to show you create view statements and explain these tables to you. So a typical table might be a type 1 dimension table, and there is no table more simple than month, VM month. And when it gets generated, VM month looks like create view VM month as select from TD0005. So TD table, D dimension, 0005. So that's the table and that's the view. And out of month, the key PKTD0005 gets changed into PKVM month. So each dimension view has PK underscore and then dimension table name. All table access is via views. You're not allowed in BI4ALL to access a physical table. You will find here a level column is set to level 2. So it defines a level for the table. So every dimension table has got a level column associated with it. And there are 10 levels defined from detail up to level 9, which is considered total. Okay. Exposes a 0 row, so you've got OR PKTD0005 equals 0. Okay. Shows you the opportunity to rename fields. Day, date is first day of month. Level column equals level 2, and rename the primary key. So this is the simplest. So the 0 row, just to explain that, is in BI4ALL to ensure no loss of referential integrity And to ensure no loss of data coming out of queries, if a dimension table lookup fails, you get to tell it what value to put in there. The default value is 0. So we say if the lookup fails to put a key on a fact table, it will get 0 in there. Now you can put anything else you like. Other customers have used -1, -99, those kind of values. We say it's 0, and if you want to change it, then you change it. Okay, but this is as simple as a view can get, and you can imagine what that view looks like. It looks like VM month with these column names. Okay, so let's pick a more complex dimension table called demographics. It's a type 1 dimension, and it comes out of table TD0001. So it says create view BI4ALL demographic as select from TD0001, where the level column equals detail, okay, the dimension table number is 101, and or the primary key is 0, in which case it's going to show a single 0 table. Okay, so this exposes all demographics for all types of parties. Notice it contains things like income low, income high, then income band. Okay, age low, age high, gender, age band. So you can do your banding like this. Okay, you can have high, low, and banding. Okay, you can have industry classification, number in household, head of household name, things like that. Because this is all demographics, and this is for people, organizations, and households. The important thing to remember here is dim table number gets a dimension table number. And so many dimension tables live in TD0001, but only one of them has got the value of 101, and that's the all demographics table. Okay. Now we would like to show you a type 2 dimension, and a typical type 2 dimension is VM product, because products change over time. So here we have create view VM product as select from TD0200. So TD0200 is the product dimension table. It has a table number of 146. We're after the detailed level, so level column equals detail. So you have PK TD0200 being exposed as PK VM product. And then you have normal things that occur for products. SKU number, barcode number, the product name, the grouping, color, bundle size, allocated cost, activity-based costing cost, less price per unit, unit of measures, discounts allowed, the discount rates. The 1 to 5 means there are 5 discount rates and 5 descriptions, but no need repeating them on the slide. Is the product returnable? When it's returned, is an inspection required? Is it a sellable item, or is it a component flag? Does it require shipping? Is it taxable? And if it's taxable, then the tax types and things like that. So they're very standard things you're going to see on a type 2 dimension. But the important 3 fields are date from, date to, and current flag. So in a type 2 dimension, you have date from, date to, and current flag. And we do type 2 dimensions at day level. We don't break them down to lower than day level. And we have seen very rare necessity to break dimensions down to lower than day level. So it's not an enforced hierarchy, just to make sure that's noted. You do have a product hierarchy here, but that's not enforced. Next thing is reporting structure is a type 2 dimension. This is because company structures change all the time. So it's a type 2 dimension is used to maintain reporting versions of a company structure. A separate recursive hierarchy is kept to maintain actual hierarchies in case of missing levels through this hierarchy. So it's again a view, create VM company reporting structure from TD0004. The dimension table number is 115, or the 0 row, and it's at the detail level. And what's coming out is the primary key, PKVM reporting structure, date from, date to, current flag. So this gives us our type 2 dimension. Then parent company, organization name, region name, channel type, category, group name, team, category, group name, person, category, group name, and we've even seen these created down to auto teller level. So if a bank has got 2 auto tellers out the front of it, then the person who's responsible for the auto tellers will have 2 records with the auto tellers, 2 rows for the auto tellers. So even down to the level of treating the auto teller as something that's necessary in the company reporting structure. So that's there. Parties. We'll go through the information on parties because that's important. As I said, parties can be people, companies, households, or anything else you want to keep as a party. A party is a type 1 dimension. Forget that next note. I've forgotten to take that off the slide. Parties are type 1 dimension. We do now have party archive. So party is always type 1 now, and party archive is type 2 if you want to implement a party archive. So party as select is VM party. Select, we've not got the fields on the left just to get more fields onto the page. So we get VM party, prefix, first name, second name, third name, address to name, concatenated name, formal salutation, informal, written salutation, email address, web addresses, tax numbers. We now have got Facebooks and LinkedIn links and things like that. Government identifiers, phone home numbers, mobile numbers, work numbers, birth date, age, VIP, your system assigned rating. We calculate the value of the person as assigned by the system, and we actually have a person assigned rating as well, where one of our staff can assign your rating. And we've got a funny story about that. I like to tell funny stories as we go along because that helps entertain everybody a little bit. The reason where these two things came from was I did a project in the Philippines once where we were assigning the rating of people by the system. And unfortunately, a lot of people who worked for the president of the Philippines at the time didn't bother paying their telephone bills very promptly, or the government didn't bother paying their telephone bills very promptly, and their telephones used to get cut off for non-payment. And of course, if you're one of the staff of the president and your telephone gets cut off, it's not a good thing. So even though there were very few phone calls being made from the telephone, and the telephone might go into debit, and you might cut it off for going into debit, it was not a good idea to cut these telephones off. And so this was where we very first came in with the idea of having somebody assigned. That telephone belongs to an important person regardless of the credit status of the telephone, so don't cut it off, because he worked for the president's staff. That's very funny, that one. We have a customer flag, employee flag, reseller flag, sales rep flags. Is paper mail allowed? Is email allowed? Gender, obviously. Then for organizations, we have organization name, the number of employees, the gross revenue, the gross profit, the net profit, the switchboard number, the startup, the years since startup, etc. Then we have blacklisted, the very important organization. And then we have a household key, very important household, customer type, short and long descriptions. And since this slide was prepared, many other things, and you can go look at them. So what types of parties are there? In the out-of-the-box model, a party can be a person, a household, organization, can be a sales rep, can be all customers, can be persons who are customers, organizations who are customers, householders who are customers, or vendors. And of course, any other thing could be put over the top of that. Now we're going to talk about parties and their dimensions, and this is the first time you will have seen an association table. And this is part of how time variant stability analysis model is implemented, and we're not going to talk too much about it here because there is a section on it which is only available under NDA. So again, we have create view, VF party dims ASOC. So what this is saying is a party is related, or a party has many dimensions, many aspects of the party. They may have their financial score, they're handled by a certain area of the organisation, they have a profession, they have certain memberships, they have a primary language, they might be blacklisted, they may have product cross holdings, they come from an ethnic group, they have a credit rating, they have a customer value, they have a loyalty code, things like that. So they're in all efforts of marketing to people, there is no end to the number of bits and pieces of information marketing people would like to have about their customers in order to better target their customers, and they like to have this information over time. Very important to have this information over time. So we just said that party was a type 1 dimension and party archive is now a type 2 dimension. What we do is we take all the information about the party that we want to archive and we split it out into separate dimension tables, fragment it into the database. And so here we have party dimensions association. We have a key for that, the actual string key, and this is the integer key. We connect the party itself. It's the obvious first thing to connect for parties and their dimensions. The first thing is the party. And then we connect everything about the party that we want to archive. And of course you can add to this. So we have in our out-of-the-box archive, primary address, behavior scores, contact preferences, reporting structure, financial score, the geography, the household, the demographics, the language, the membership indicators, profession, psychographic indicators, blacklist type, blacklist reason, product combination holding indicators, and product cross holding indicators, two different things, the ethnic group, the credit rating, customer value index, and loyalty code. And then very importantly, we have date from, date to, have a current flag, we have the type of the party, and we have is the party blacklisted as redundantly stored, and number of parties is set to 1. We have an association code and a role and an amount of the association there. That's between the party and the whole set of information that's being associated. We put that on there just for safekeeping from a specific table. Now the important thing to remember, we have VM date from, VM date to put out to the actual dimension tables, as well as the actual date from, date to. So if we have date from, date to with the keys and the current flag, when something like my demographic changes, I'm going to close one record and open a new record. So let's say I have a birthday, and in fact I just turned 50 a couple of weeks ago, and normally you'd have 45 to 49 and then 50 to 54, right? In your demographics. So on the event of my 50th birthday, if we implemented the data warehouse, it would calculate a change in the demographic record. And what it would do is automatically close the party dimensions association for me for my old demographic record and open up a new one in my new, linked to my new demographic record. Now obviously if I take this party and connect all these dimension tables, these 25 or so dimension tables, to the actual dimension tables, and I write this query and I show all the data in all the tables, I am obviously going to get an image of the change of everything that happened to this party. But I'm going to get it stored in a very compact way with a set of integer keys. Now this implements time variant stability analysis perfectly, okay, perfectly. And I'll go into that in a little bit more detail, but this is the table, this is the style and design of table that implements time variance and stability analysis in a dimensional model. Now we'll go through some more tables. The psychographics is an indicator table, and by indicator table we mean we just have a set of flags set to yes and no, which makes a matrix of all the things that can be said to be true about a certain party. And you saw that psychographic indicators was on here. So here's VM psychographic indicators is linked to party via party dimensions association. So each version of the psychographic indicators tells you all the things that are flagged for this person. And as I said, you know, smoker, owns a car, owns a house, has a mortgage, gold Visa, gold Amex, pet food, dog food, internet user. Well, that's everybody today. Computer games flag, water sports, small motorcycle, small large car, those kind of things. Anything that you can get from your profiling of customers could very well go into the psychographics table and indicator. Now, the indicator tables are tables that contain sets of flags to easily focus in on specific values of yes or no. There are only as many rows in the indicator table as exist inside the source data. We long ago invented a method where we no longer need to build a row for each combination of fields because those tables became too large. So we got rid of that problem. There can never be any more psychographic indicator rows than there are actual historical combinations in the data. Okay, we got it down to that. Things like account indicators. For an account, you might have credit is allowed or not, payment on days, 15, 30, 45, etc. Is there an interest penalty when they go over? Is there a monthly fee? Is there an annual fee? These kinds of questions are on indicator tables. An address indicator table would have something like, is there a weather hazard? Just this week, if you go back and read the 14th of February the 11th of February 2014, you'll notice that lots of areas around London capital are flooding. So you would have a flood hazard or a storm hazard or a weather hazard like cyclone, a hurricane hazard, drought hazard, earthquake hazard. So you have various address indicators. Product cross-holding indicators. Sometimes you want to know who owns a combination of products, and sometimes you want to know who owns a combination of products but not some other specific product. And that's much easier to do with product cross-holding tables. So this is, does the person hold product 1, 2, 3, up to product 20? Yes, no. So this is very useful when you have a fairly limited set of products. And this is perfectly describing a telephone company, which generally only has 8, maybe 10 products that you can buy. And they're very keen on upgrading you to take extra products. So in a telephone company, it's really important to know which products does a person hold and which do they not hold, and can we which people who don't hold a product should we offer that product to, at what price? This is very important to know in a telephone company. Now, in terms of associating parties, parties can be associated for a reason and in a role for a period for a specified amount. So, for example, a company can own another portion of a company for a period, and the portion of the company ownership can change over time. Or a person can own a portion of a company for a period, and the portion of ownership of a company can change over time. Okay, so for party associations, we have to have party 1, party 2, the association code, the association role, and the date from date to with a current flag, and then the code descriptions themselves and the amounts 1 and 2. We put 2 types of amounts on there, and the type of each party, and that gives us this ability to relate parties. And this very simple table gives us a very sophisticated set of combinations that we can then build for party-to-party relationships. Now remember, a party can be a person, household, organisation, sales rep, all customers, person customer, organisation customer, household customer, and vendor. And many of these associations are exposed separately through their own views. And now we're going to talk about parties and addresses. Most people stick the address information in with the party, which is always a big mistake, because an address is independent of a party. An address exists even if no one lives in the house, or an address exists even if nobody lives there. Indeed, business addresses exist even though nobody lives there. Okay, so we consider addresses quite independent of parties, and our VM address table then gets associated with the party record in order to associate the address with the parties. And of course, parties have many addresses. We all have, nearly all of us have a home address and a work address, right? So we have a home address, a work address, but we might lease out storage, and the storage might be at an address, and we might want to be associated with that address as well. So there can be quite a few different addresses that are linked to an individual person. So it is quite simple. A party is linked to an address for an association code and role from to with a current flag and some association amounts. So that's how parties and addresses are associated. Now I just want to take you through some simple fact tables to give you the feeling of what a fact table looks like before we do our source code demonstration. Okay? So we're going to look closely at a couple of fact tables, and the simplest fact table is the account close transaction. So every time an account closes, there will be a transaction generated for the close, so we can look into account closes. So notice PK underscore, PK VF account close transaction. Every fact table has an integer key on the front, which is a primary key. This is unusual. We don't know anybody else who does this. I did this in 2002. So in 2002, it first struck me that if we put a generated integer key on the front of every fact table, we could build into the mesh, what we now call the mesh, we could build into the mesh relationships directly, fact table to fact table. So we could join fact tables to fact tables directly if we put integer keys on fact tables. This was a very radical idea at the time, and I remember talking about it and saying to people, hey, you should put integer keys on the front of fact tables. You'll find that there's some really useful things to do with them. And one person wrote back on the discussion group, I can't think of one single useful thing to do with an integer key on a fact table. And I wrote back to him and said, I believe you. I believe you can't think of one single useful thing to do with a integer key on a fact table. And I don't even think he got that I was insulting him. I don't think he understood that I was insulting him. But of course I was, because we had found lots of really useful things to do with integer keys on fact tables, and we were doing them. And I gave away the idea and said, hey guys, you should put integer keys on fact tables. And I was ignored. And now it's 2014, it's 12 years later, and I very rarely see anybody talk about putting integer keys on fact tables. Meanwhile, myself and my colleagues and business partners, etc., have busily been putting integer keys on fact tables for a decade, and they have a lot of great uses. So we put integer keys on fact tables, and we can look up fact rows for updates through our integer keys. We can link associations through the integer keys and things like that. Okay. So then the dimension tables are linked. You can see you've got the account transaction date and minute, and the account, the sub-campaign, the contact method, the product, the customer demographic, the currency, the unit of measure, geography, geocode, map references, card type, card, transaction type, sales representative, the account reason code, account close reason code, the company reporting structure, the account Dimensions Association, the Customer Dimensions Association, and the Campaign Dimensions Association are all on the account close transaction, because you want to analyze this table to death, because this represents a closure of an account, and you want to find out why the accounts are closing. So you can see the number of keys on there on the fact table, and this is very typical of BI4ALL fact tables, that we have lots of keys. So you notice we say the three keys: Account DIMS Association, Customer DIMS Association, Campaign DIMS Association. We'll put more on those later. Notice also that we then have the transaction amount, transaction units, and the transaction's timestamp, which is just some of the very standard information you would want on an account close. Now, on an account close, there may be lots of other information you want, but the standard common information you're going to find anywhere you go is the amount, the units, and the timestamp. You're also going to find a short and long description, and you're also going to find the APSYS reference number string. This means the application system reference number expressed as a string, not as a number. So on virtually every fact table, we have the application system reference number string, so that if we need to, we can get from this record back to the application system and look up the key on the application system. So this is like the simplest fact table that we have in BI4ALL. Let's look at an invoice line. Invoice lines, very standard right across organizations. Again, another very simple fact table. Note down here, DKVF invoice header. Note that. So invoice lines, note link to invoice header fact row. So DKVF invoice header, here we have linked the invoice line directly to the invoice header through the integer key of the invoice header. Kind of cool. That people can't figure out that's useful, and what to do with it, that's their problem. It's there, and trust me, it's useful. So we have a primary key for the invoice line. We have all the standard things for invoices, right? You need an account, a product, customer, currency, geography, order date, company reporting structure, statuses, etc. So you can hit pause and read them as well as I can read them out. You need then an application reference number, application system reference number, so you can get back to the reference number for the application. You need the invoice number, which may be a number or a string, and we store both because invoice numbers are so common. And then what is standard on an invoice line? What's standard on an invoice line is the line number itself, the number of units, the base amount, extra amounts, tax amounts for units, and then the extended base extra tax amounts. And putting 2 tax amounts on is probably pretty stingy, given the way things are taxed today. Then the line short description, the line long description, comments against the line, the date it was ordered, the scheduled delivery date, the scheduled payment date, and the number of lines, which would be set to 1. So these would be very, very common information on invoice lines. And what we said up front was we give you the really common information, yeah? And if you want something else, you add it to the view when it's created. So we're giving you the common information, you add it to the view when it's created. Now, what we're going to do now is to give you a source code and database demonstration of everything that we just showed you. So that section is currently running at 78 minutes 50 seconds. Okay, so that's quite a long demonstration. We've taken you through the names of all the tables and a short description, just verbal short description of everything there. Now we do have all this in a database, right? And all the descriptions of all the tables are in the database through the spreadsheet, which you're about to see. And what we do is we can just run off a report, okay? So rather than go through it in detail, we can, if you want, give you a report under non-disclosure agreement of all the table names and all the descriptions of all the table names, okay? And you can sit there and read it for yourself because that's part of the data model, okay? So what we'll do now is we're going to end this presentation and break. You might want to take a break given that it's 80 minutes, because this next session will also be fairly long, taking you through the base BI4ALL product database demonstration and source code presentation. So with that, I'll say thank you very much for listening, and I'll welcome you back when you come back for part 2 of part 2. Thank you very much.